Lesson 1.7 is representing functions as graphs. As we saw in 1.6, the input values are the x values and the output values are the y values. You can graph x and y values on a coordinate plane, and you have. The example here is asking you to graph y equals 1/2 x. They tell you what the domain is. Remember, those are the x values or the inputs. So what we're going to do is create an input-output table and plot the points. Your input-output table can be horizontal or it can be vertical. Here I've drawn a vertical input-output table. So you'll see under the x all the values that are included in the domain. I substitute those values into the equation. Okay, so you take these and substitute them in here. Okay, so we put the x values in and we calculate the y values. So now we have the input and the output. Now remember, the x values go along the horizontal axis and the y values go along the vertical axis. So all I've done is plot the points. 0, 0, 2, 1, 4, 2, 6, 3, and 8, 4. And those points are in red so that you can see them. There are several things that you have to consider when graphing and choosing a scale for your graph. You have to look at the domain and range, and you choose intervals that make sense for your data. It doesn't have to go by ones. It could go by tens. It could go by 20s. It could go by hundreds or thousands. You don't have to have the same intervals on the x and y axis. Okay? You could go by ones on the x-axis, but go by 100s on the y-axis, for example. But x will always be horizontal and y will always be vertical. If time is involved, x is always time and it is on the horizontal axis. If we look at the data here, which reflects SAT scores in the United States, okay, we have the years since 1997, that's T or time. So the years since 1997, so the year 0 would be 1997. The year 1 would be 1998, and so on. The average score, S, is given for each year. We're going to choose a scale. Now, since the t values are increasing by 1, t should probably go by 1s on the x-axis. Remember, time is always on the x-axis. The s values are in the 500s, but it's a really small range in the 500s. The lowest one is 511, and the highest one is 519. Okay? So what I would consider doing, instead of going up by even 100s all the way up, have a little break in the y-axis, and you denote it by that little red symbol there, and begin your scale at 500. You could increase by 2s or increase by 1s going up. Okay? So the graph would look something like this. Okay? You need to include a break mark on the axis if you are not starting at 0. Okay? So make sure you put that little break mark in so you're eliminating part of the axis. And again, time is always on the x-axis. You also have to be able to look at a graph and put the data in an input-output table and then write the rule for the function. So if you look at the graph below, you'll see the red points that I have plotted. You have to write an input-output table. So you'd look at the graph. For the first point, for example, is 1, 2. So in the x part of the input-output table, you would put 1. The y would be 2. The next point is 2, 3. Remember, all points on a coordinate plane have 2 numbers associated with them. The first one is always the x-coordinate. The second one is always the y-coordinate. So I've gone through each of these points, and I've created the input-output table based on those points. Make sure you can see where I've gotten these numbers. Now, looking at the table, you have to write a rule for the function. That means the equation, right? And it should be in the form y equals something. Because remember, y is the dependent variable, and x is the one we're putting into the equation. Look at the relationship between x and y. We have 1, 2. 2, 3. 3, 4, 4, 5, 5, 6. So in this case, y is always 1 more than x. So y equals x plus 1. The summary of this lesson is that you can represent a function in several different ways. You can state the relationship between x and y in words. For example, y is 2 more than x. Y is 1/2 x. Y is 2 times more than x plus 3. You can write an equation for the relationship. Y equals 2x minus 1. Y equals 2x plus 4. Y equals 1/2 x minus 5. You could also make an input-output table to show the values for x and y. Or you could graph the function.